In 1977, humanity launched a spacecraft that was never expected to become a legend. Voyager 1 was designed for a planetary mission. Its primary task was to travel through the outer solar system, observe distant worlds, collect scientific measurements, and send the information back to Earth. No one could have predicted how long that mission would eventually last. Decades later, Voyager 1 would become the most distant human-made spacecraft ever sent into space. Think about the technology available when it launched. There were no modern smartphones, no global internet, and personal computers were still in their infancy. Yet this small machine continues to operate across an environment billions of miles from Earth. Its journey began with an extraordinary opportunity. During the late 1970s, the outer planets were positioned in a configuration that allowed spacecraft to use their gravity to gain speed. This technique, known as a gravity assist, allowed a probe to effectively borrow energy from a planet's motion and redirect itself toward another destination. The opportunity was rare. NASA took advantage of it by sending Voyager 1 and Voyager 2 into space. The two spacecraft transformed our understanding of the outer solar system. Voyager 1 flew past Jupiter and Saturn, capturing observations that revealed these distant worlds in unprecedented detail. But the planets themselves were only part of the story. Their moons turned out to be extraordinary. Jupiter's moon Io displayed active volcanic eruptions, proving that a small world could possess an astonishing amount of internal activity. Europa presented a completely different mystery. Its icy exterior hinted at processes occurring beneath the surface, helping establish the idea that some apparently frozen worlds could hide liquid environments underground. Voyager's observations of Saturn and its moons provided another collection of surprises. Meanwhile, Voyager 2 continued farther outward, eventually becoming the only spacecraft to visit both Uranus and Neptune. These encounters transformed distant points of light into actual worlds with atmospheres, storms, magnetic fields, moons, rains, and complicated geological histories. Yet the most remarkable part of the Voyager story came after the planetary encounters were over. Instead of shutting down, Voyager 1 continued outward. Eventually, it approached the enormous boundary where the Sun's influence becomes much weaker and the surrounding interstellar environment begins to dominate. This region is known as the heliopause. Scientists expected the transition to produce dramatic changes. Solar particles should decrease. Galactic cosmic rays should become more prominent. The spacecraft's measurements of plasma and magnetic fields should reveal that it had entered a fundamentally different environment. But nature did not provide such a simple boundary. Voyager's measurements showed that the transition was much more complicated than scientists had imagined. The spacecraft detected a major change in the particle environment, but the magnetic field direction did not suddenly rotate in the way some researchers expected. This raised an important question. Had Voyager actually crossed into interstellar space? Scientists continued analyzing the data. Then came the critical evidence. Measurements of the plasma environment indicated that Voyager 1 had entered a region with a much higher density of particles than the solar wind typically found inside the heliosphere. The evidence eventually established that Voyager 1 had crossed the heliopause in 2012. For the first time in history, a human-made spacecraft had entered interstellar space. But that did not mean the mission was finished. Quite the opposite. Voyager 1 was now exploring an environment humanity had never directly sampled before. Beyond the Sun's protective bubble lies the interstellar medium, the extremely thin material between stars. Here, Voyager could study cosmic rays, plasma, magnetic fields, and other phenomena that cannot be fully understood from Earth alone. The spacecraft had transformed from a planetary probe into something much greater. It had become humanity's first messenger into the space between the stars. and its journey was only beginning. Voyager 1's greatest achievement may not have been photographing Jupiter or Saturn. It may have been crossing the boundary separating our solar system from the surrounding interstellar environment. Once Voyager entered this distant region, scientists gained something extraordinarily valuable: direct measurements from a place no previous human spacecraft had ever reached. The heliopause turned out to be far more complicated than a simple invisible wall. Instead of a perfectly defined border, it appears to be part of a dynamic transition zone where the solar wind interacts with material and magnetic fields associated with interstellar space. Voyager's measurements helped scientists understand that the edge of the Sun's influence is not static. It is constantly responding to the changing solar environment and the conditions of the surrounding interstellar medium. That discovery alone changed how researchers think about the boundary of our solar system. But Voyager's importance extends beyond one region of space. Every measurement it sends home represents an opportunity to study the environment between stars. The spacecraft can investigate energetic particles and cosmic radiation that have traveled through the galaxy for enormous distances. These observations help researchers understand how particles move through interstellar space and how the Sun's influence protects the planetary system surrounding it. And the fact that Voyager can still communicate after so many decades is extraordinary. Its systems were designed in an entirely different technological era. The spacecraft carries computers that are primitive compared with modern consumer electronics. Yet those systems were engineered for reliability, and NASA has gradually switched off instruments and systems that are no longer essential in order to conserve the spacecraft's remaining energy. Voyager's power source is a radioisotope thermoelectric generator. It converts heat produced by radioactive decay into electricity. But that energy supply is not infinite. As the radioactive material gradually decays, the available electrical power decreases. Eventually, Voyager 1 will no longer have enough energy to operate its scientific instruments or maintain communication with Earth. When that happens, the spacecraft will not suddenly stop moving. It will continue traveling through interstellar space. Silently. Its trajectory will carry it farther away from the Sun while Earth becomes a smaller and smaller part of its distant history. And Voyager carries something particularly meaningful with it. Attached to each spacecraft is the Golden Record, a carefully assembled collection intended as a symbolic message from Earth. It contains sounds, music, images, and greetings representing our planet and its inhabitants. The record was never designed as a practical communication system. It is a time capsule. A statement that says humanity existed, looked toward the stars, and wanted to leave something behind. Eventually, Voyager 1 will continue traveling long after its instruments become silent. It will drift through the galaxy while stars move around it and the solar system continues its own journey through space. The spacecraft will no longer send photographs. It will no longer transmit measurements. But its physical journey will continue. That is what makes Voyager so extraordinary. It began as a scientific mission to explore a handful of distant planets. Instead, it became humanity's first expedition into interstellar space. Its discoveries changed our understanding of Jupiter, Saturn, their moons, and the outer solar system. Its measurements at the heliopause revealed that the boundary of the Sun's domain is much more complicated than scientists once believed. And its continuing journey demonstrates something even more fundamental. Human exploration does not always require humans to physically travel somewhere. Sometimes we build machines capable of going where we cannot yet go ourselves. Voyager 1 is one of those machines. It carries the scientific legacy of the people who designed it, the engineers who kept it alive, and generations of scientists who continue studying its faint signals from unimaginable distances. One day, those signals will finally stop. But Voyager itself will continue. A small machine built in the 1970s will keep moving through the darkness between the stars, carrying a record of Earth farther than anything humanity has ever sent before. And perhaps that is the most powerful part of the Voyager story. The spacecraft was launched to explore the solar system. Instead, it became humanity's first step toward the stars.